So today we're going to be talking about the four-color theorem.
The four-color theorem is given any separation of a plane into contiguous regions, producing a figure called a map. No more than 4 colors are required to color the regions of the map so that no two adjacent colored regions have the same color.
Now, for a brief history of the four-color map theorem. First, in 1852, Francis Guthrie was a student at the University College in London. While coloring a map of England, he discovered that 4 colors were sufficient for coloring the entire map where no colors touched. So he went to his professor, Augustus de Morgan, and he asked him if there was a way to prove this theorem.
Then, in 1879, Alfred Bray Kempe thought he had proved the theorem. But then, 11 years later, another scientist or mathematician disproved him.
Then finally, in 1976, Kenneth Appel and Wolfgang Haken proved the theorem. But the only reason that the theorem was proved was by using 3 high-speed computers to prove over 1,000 calculations. This being said, many mathematicians don't believe that it has actually been proved since it has never been proved by hand.
Now for a brief example of how the four-color map theorem works. This is how mathematicians originally proved the theorem, by figuring out that no 4 colors could touch by using points and lines on a graph. So first, we start with a single dot. Point. Okay. This point is representing a country. We can then have another point on the same graph in the same plane, and they are connected because they are in the same plane, and this connection, the line, means that they are touching, or that they have to be different colors. We can add a third dot, also in the same plane as both of these, so that it has to be touching both points. Now we have 3 different colors on the map. Now we have 2 planes, however. Plane 1 and plane 2. No matter where you put the next dot, in plane 2 or plane 1, it could only touch 3 different points. As an example of this, we will start by putting a dot in plane 2. As you can see, it can only touch 3 points, mainly because there are only 3 points in the graph. So all 4 of these are different colors because they are all connected to each other. Now, if we were to put a graph in another plane, keep in mind now there are 4 planes, 1, 2, 3, and 4. No matter where we put the dot, it could still only touch 3 points. As an example, we'll start by putting a point in plane 1. As you can see, this point can only touch 3 other points, making all 4 of these different colors. So, for instance, if we put another point here, 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 or anywhere on the outside, it could still only touch 3 points in its plane. Now, if we were to add colors to these dots, as you can see, it wouldn't matter because they are all in different planes and only 1 dot is touching 3 others, we only need 4 colors. So if this country was red, this one would also be red because it is not touching it. Then we can have the 3 other countries. Green, blue, and black. Obviously this isn't a very pretty drawing, but you understand that the 2 reds cannot touch, and if we were to add another point, it could also not touch the, never mind, I just lost it. Okay, but we can just cut that off right after I do the colors. Okay. Now we see a more complicated version of the point and line way of solving the four-color map theorem with a map of Europe. As you can see, within this map, there is our original triangle that we made in the last example. As well as several other points throughout Europe. However, this also proves that even in more complicated maps, whether it be this many, say 20, or up to 1,000 different countries, that you can color the entire map using only 4 colors.
This is how the four-color map theorem was proved by Wolfgang Haken and Kenneth Appel.
The mathematicians used a computer to help them figure out all the different calculations on all the different maps to prove that you only need 4 colors in one map. They used 1,500 maps to prove this, and it wasn't actually proved by an equation, but by proving that 4 colors were sufficient for all these maps. They also tried several different numbers of colors, such as 3, 5, 6, 7, 8, any number you could imagine, to show that 4 was the minimum that you needed to color in an entire map. So they tried 1,500 different configurations of all different shapes and sizes to prove this, and they used a total of 1,000 hours on 3 high-speed computers to do so, which
showed that this proof could only be proven by computer, and it has never been proved by hand. And this proof has been proved by using examples and showing that 4 colors are all that is needed to color the maps, not by a mathematical equation that you could simply write down and go through and just find the number of colors.
So, although it has been proven by an equation and actually simplified in later years by other mathematicians, so that you only need 633 configurations to figure out that you only need 4 colors, it still is not really truly proven by hand, and therefore mathematicians and scientists aren't completely sure of its truth, but
Challenge time!
Okay, so it is now time for the challenges. There are 2 simple maps that you are going to try to figure out to see how well you've learned the 4-color theorem. So remember that no borders can touch being the same color. So here's your first one. So now for the answer to your challenge. So first we'll start off with green. We'll put some green up here, and then in a circle, and then again at the bottom. And we'll take some blue and we'll put that over here, along with inside one of these pieces. And then take red and put that in these 2 spaces, along with then some black over here, and then in this far edge. And then you can take one last final color and go all the way around the outside of the circle. And then none of the colors are touching, but all the borders and pieces are colored in.
Now it's time for your second challenge. See if you can color in this portion of Europe with only your 4 colors. Let's see if you guys colored in the map correctly. We'll start with Germany and colored in 1 color. Now the country that matches with Germany is Slovakia. Next we'll color in Poland. Poland's match is Austria. Now you can color in Switzerland. And Switzerland's match is Slovenia. And then finally, you color the Czech Republic, Hungary, and Italy, all the same color. So no color is touching a country of the same color. This is a much prettier version of that map in which we will show that the point and line drawing is still used to show that only 4 colors are needed. As you can see, I'm very magical and I can do this without my hands. And as you can see here, and now there's a smiley face over by my face, that all of these regions are not touching colors that are the same as their own.
Okay, so here is a map of the whole world showing only using 4 colors to color in all the different countries. So up here is the Europe map, which you guys colored earlier. And then as you can see in Africa, with all the different countries, they still only use 4 different colors. And then over in Asia, all the different small countries in here are all still colored in by only 4 colors with no colors touching. And then there's the United States map along with South America, which still is using the 4 colors. The mathematicians had to use a full-scale map like this to try and figure out all the different color combinations. So they plugged in the different colors into all the countries to figure it out.
In addition to this, they also figured out if they were to divide each country into different regions and states, such as the United States with all 50 states, they could still be no colors touching throughout the entire world if they were to divide each country into different regions. They cannot do this by hand very easily and make a big enough map for us to be able to see today, but on the computers that they used to prove the theorem, they did a lot of things like this with extremely complicated maps that only computers could solve. One, two, three.
We hoped you learned something.
Thanks for joining us today.
The color show.
And done.
And
God, you're so awkward.